Welcome back, mathematicians. In this video, we are going to discuss the complementary angle theorem. The theorem states that cofunctions of complementary angles are equal. Looking at the triangle below, we have a right triangle. We know that the sum of the interior angles of any triangle is 180 degrees. As a result, angle A plus angle B plus the 90-degree right angle is equal to 180 degrees. Subtracting 90 degrees from both sides, we see that angle A plus angle B is equal to 90 degrees, which means that angle A and angle B are complementary. Let's continue to analyze the triangle in terms of sine and cosine. Let's look at the sine of angle B, and we see that the sine of angle B is equal to the opposite side, which is B, over the hypotenuse, which is C. We also see that the cosine of angle A is the same ratio. As a result, we now know that sine of angle B is equal to cosine of angle A. Sine and cosine are cofunctions of one another, and we already determined that A and B are complementary angles. We also know that cosecant and secant are cofunctions of one another, and we again have already established that angle A and angle B are complementary angles. Finally, we know that tangent and cotangent are cofunctions, and we've already established that angle A and angle B are complementary angles. As a result, we can say that cosecant of angle A is equal to secant of angle B, and tangent of angle A is equal to cotangent of angle B, as long as A and B are complementary angles. Let's now use that theorem to find the exact value of each of these two expressions. We'll start with secant of 11 degrees minus cosecant of 79 degrees. What we can see here is that 11 degrees plus 79 degrees is equal to a sum of 90 degrees. This means these two angles are complementary. We also know that secant and cosecant are cofunctions. As a result, we know that secant of 11 degrees is equal to cosecant of 79 degrees based on the theorem. What we can now do is replace either trigonometric function with its cofunction of the complementary angle. It doesn't really matter which one you choose. I will simply choose the first one just because it is first. And so I will replace secant of 11 degrees with cosecant of 79 degrees because they are equal. We still are subtracting cosecant of 79 degrees. And so the result is that the difference of these two trigonometric functions, given that they are the exact same, is going to be 0. Let's do the same process for the second problem, where we have sine of pi over 10 over cosine of 2 pi over 5. So first let's identify the fact that these two angles, pi over 10 plus 2 pi over 5, if we get a common denominator, we'll have pi over 10 plus 4 pi over 10, which is equal to 5 pi over 10, and we reduce that, and what we end up getting is pi over 2. This tells us that those two angles are complementary. As a result, we know that sine of pi over 10 is equal to cosine of 2 pi over 5, because pi over 10 and 2 pi over 5 are complementary, and sine and cosine are cofunctions. I'm now going to replace one of the trigonometric functions in the ratio with its cofunction of the complementary angle. It doesn't really matter which one you choose, so I'm going to choose the numerator and replace sine of pi over 10 with cosine of 2 pi over 5. The denominator doesn't change, so it's still cosine of 2 pi over 5. And because we have the same trigonometric function in the numerator and denominator, evaluating the same angle, we know that the ratio is equal to 1. All right, guys, good luck.